So the worksheet wants us to identify, let's read this. It says identify the coefficients, okay, and then also identify the constants. So I'm going to write an example on the paper. If I say 3y, that is a term where the number 3 in the front is what we call a coefficient. So that's the coefficient. And what that means is it's just the number in front of a variable. So this is the coefficient. Remember, whatever I write down, you write down. So that's just COEF for coefficient. Now, if I don't have a variable, in other words, I have -7. Because there's no variable, I'm going to call this a constant. Now, constant means that -7 will always be -7. Okay? So it's constant. In other words, that value never changes. It's constant. So a coefficient is in front of a variable, and that is subject to change. So if I look at this and it asks me to do the coefficients and the constants, the coefficient is any number in front of a variable, and it's just the number. It's just the number that's in front of the variable. Okay, and we're going to write this down in a second. So I'm going through and I'm looking at every one of these, and I'm identifying which one has a number in front of the variable. Okay, then I'm going to go through and identify just the numbers with no variables, because those are my constants. Okay. So on this first one, if I were to make a chart, the coefficient is 64, and then the constant is 24. So what I want you guys to do is I want you to circle the coefficients and underline the constants. So I'm going to circle just the coefficient and underline the constant. I'm going to circle just the coefficient and underline the constant. Technically, I should include the sign in front of it. So I'm going to circle the coefficient, and underline the constants. Okay? Now that's important because we're getting ready to talk about slope and linear equations. And linear equations, just jot this down on the bottom, they look like this: y equals mx plus b. And so as you can see here, the m represents a number, which would be a coefficient, right? And b is a constant because it does not have the variable x. So that's what we're leading up to, because we're going to talk about the rate of change and the slope of a line, which these two terms mean the same thing basically. So now let's turn our pages over. All right, we're going to turn our pages over, and then on this side we're being asked to compare the ratio. So in other words, for each triangle, write a ratio that represents the relationship between the height and the base. So we're going to write a fraction, because that's what ratio means, between the height and the base. So when it's written that way, what we want to do is we're going to write down the height over the base. Why? Because that's how it asked us to compare it. It said a ratio between the height was first, so that goes on top as the numerator, and then it said and the base. That goes on bottom. Now if I identify the height of each triangle, most times we think of going from the ground up as being the height. So I look at all four triangles, and those are the heights. And the base, we think of like what's sitting on the ground. And so now if I'm to write these fractions, I would write 10 over 10. The next one is 15 over 4. This one is 15 over 15. And the next one is 12 over 3. Okay? Now in the next line, it asks us to write each ratio as a unit rate. So now a unit rate means that there is a 1 in the denominator. So there's a 1 in the denominator. Okay? So now I could do that by simplifying the fraction in such a way that there's a 1 in the denominator. So what I could do is I could say 10 over 10. If I think in my head I'm going to divide the top by 10, remembering whatever I do on the bottom I divide by 10, I get 1 over 1. So that's the first unit rate. On the next one, I have 15 over 4, but we could treat that like 15 divided by 4. Now that's not gonna, 4 does not go into 15 evenly, so my unit rate will have to convert to a decimal, but that's okay. So what I could do, remembering that fractions are actually division problems, I'm going to take my calculator and I'm going to say 15 divided by 4 and plug that in my calculator, and I get 3.75. And really what that means is this is 3.75. Okay, so this is like figure A, this is like figure B. Now for figure C, we do the same thing. We're going to take 15 and divide it, 15 divided by 15, because that's my ratio. I've got 15 divided by 15. We all know that that's 1. So for figure C, my unit rate is 1. And then for the next one, what do I plug in the calculator? You got it, 12 divided by 3, which is 4. So for figure D, I'm just going to put it down here. Figure D, we got 12 divided by 4, which equals 3. Now there's an interesting concept here. This concept of slope or rate of change is like the steepness of a line. First, let's examine the lines or the triangles. If I were to look at this hypotenuse of every triangle, which figure looks like it's the steepest? Which one looks like it's the steepest, like it's turned the most, almost straight up and down?
B.
B or D, right?
Yeah.
Probably B. Now what do you notice about the ratios, the unit rate? This one is 1. This one is 3.75. In other words, if I look at the unit rate, this unit rate for this one, whatever I write down, you write down. This one has a unit rate of 3.75. This one has a unit rate of 1. And then this one has a unit rate of 3. So if you were to say B based on the unit rate, would you be correct? Yeah, the steepest one is the one with the ratio 3.5, with the greatest ratio. Okay, so now question number 3 says, how can you use these rates to compare the steepness of the triangle? Well, if I were to put them in order, I could say figure, let me slide this up a little bit. Figure B is the steepest because it has the greatest height to base ratio. Does that make sense? What could you say about figures A and C with regards to their steepness? They have the same unit rate, so they have the same steepness.